Section 4.4.7 Nth Roots of Unity. For Leaving Cert Maths Higher Level Only, this video was produced by the UCD Maths Support Center in conjunction with the UCD Access Center. Previously we saw how to solve z to the power of 3 equals 8. Now we're going to solve it using de Moivre's theorem. So firstly we need to write our right-hand side in polar form. So 8 is 8 plus 0i, which becomes 8 cos 0 plus I sine 0. Now the trick here is to set z cubed equal to this right-hand side, but we're going to add a 2n pi to the argument. So we get 8 cos 0 plus 2n pi plus I sine 0 plus 2n pi. And we're going to let n equal different values to give us our roots. We want to find what z is, not what z to the power of 3 is. So let's take both sides to the power of a third, and then the right-hand side becomes 2 cos 2n pi over 3 plus I sine 2n pi over 3 by de Moivre's theorem. It's a z to the power of 3, so there are going to be 3 roots. N starts at 0, and then we're going to take it as far as 2, so we've got the first 3 possible values of n, 0, 1, and 2. So the first case, n is 0. What's z when n is 0? So we sub in 0 for n, we get z is 2 cos of 0 plus I sine of 0, and now we evaluate this. So cos of 0 is 1, and sine of 0 is 0, so we get 2. So z equals 2 is our first root. Second case, let's sub in n equals 1. So z becomes 2 cos of 2 pi over 3 plus I sine 2 pi over 3. Evaluating that, cos of 2 pi over 3 is minus a half, and sine of 2 pi over 3 is root 3 over 2. Multiplying out our bracket, I get minus 1 plus I root 3. And in the last case, z equals 2. So subbing that in, I get z is 2 times cos 4 pi over 3 plus I sine 4 pi over 3. Cos 4 pi over 3 is minus a half. Sine 4 pi over 3 is root 3 over 2. Multiplying out my bracket, I get z is minus 1 minus I root 3. So therefore, the roots are z equals 2 and minus 1 plus or minus I root 3, which is what I found earlier.